Talking about Unit 2, Notes 1B. So today we're going to be talking about graphing systems in standard form. So it's really a lot like we did on the previous note sheet, except this time they're going to be in standard form. So we're going to have to do a little bit of solving in order to graph them. So let's start by taking a look at number 1. So before we can graph number 1, we have to get it put into standard form. So to do that, I need to first solve this one. So I have 2x minus y is equal to a negative 3. Now the first thing I want to do would be to solve for y. Okay, so I'm going to start by subtracting 2x from both sides. So what you notice is this is a positive 2x. So to get it over to the other side, I need to subtract 2x. So then I get negative y is equal to negative 2x minus 3. So now I need to divide both sides by a negative 1 because I don't want to know what negative y is. I want to know what y is. So then these are each converted to positive. So there's the first line we're going to graph. We're crossing the y-axis at a positive 3. And then we're going up 2 over 1. And then we're going to draw a line through that. Okay, now let's take a look at this next one. So I'm going to go ahead and I'm going to erase this work so we don't get it all conjumbled here. And let's take a look at 8x minus 4y is equal to negative 12. 8x minus 4y is equal to a negative 12. So the first thing we want to do is get the positive 8x over to the other side. So to do that, we need to subtract 8x. So then I have a negative 4y is equal to a negative 8x minus 12. Next, we need to divide both sides by a negative 4. And then I get that y is equal to negative 8 divided by negative 4 is going to give me a positive 2. Negative 12 divided by negative 4 is going to give me a positive 3. Well, lo and behold, we've already graphed that line. We graphed it right here. So it ends up being the same line. So that makes our solution IMS, or infinitely many solutions. Okay? Next, let's take a look at this guy right here. So again, we have to solve to get it into standard form. So let's go ahead and solve that first one out. So we're going to take this guy right here. So we have x minus 2y is equal to 4. So now we're going to subtract x from both sides, and then we get a negative 2y is equal to a negative x plus 4. So then we're going to go ahead and divide both sides by a negative 2. All right, so then when we do that, negative x divided by negative 2, well, that's going to be positive, and that's going to stay the same as 1/2. Okay, so that's going to become 1/2 x, and then 4 divided by negative 2 is going to give me a negative 2. So we're crossing the y-axis at negative 2. Then we're going to go up 1 over 2 and plot that point. And then we're going to go ahead and then connect our two lines. So hopefully you guys are at the point where you're comfortable graphing lines. If that's something that's still not the most comfortable for you, let me know so we can get you some help on that, okay? So let's go ahead and we're going to erase this guy and we're going to go ahead and solve the second equation. So for the second equation, I have x minus 2y is equal to negative 2. So the first thing I want to do is subtract x from both sides. Again, this is a positive x. So to bring it over to the other side, I need to subtract x. So then I get a negative 2y is equal to a negative x minus 2. Then we're going to divide both sides by a negative 2. So then we get y is equal to negative 1 divided by negative 2. That's going to give me a positive 1/2 x. And negative 2 divided by negative 2 is just going to give me 1. So for this one, we're crossing the y-axis at 1, and then we're going up 1 over 2. And we're going to go ahead and draw a straight line there. So the lines don't cross, and so then this is no solution. Okay, because they don't cross each other, so then the two have no solution. Let's take a look at the next couple of systems here. So first of all, let's solve that first equation. So 2x plus y is equal to 4. So we need to solve that equation for y. 2x plus y is equal to negative 4. So then we're going to go ahead, and again, it's a positive 2x, so I'm going to subtract 2x from both sides. And then we get that y is equal to negative 2x minus 4. Okay, so we're crossing the y-axis at negative 4. And then we're going down 2 over 1 and plotting that point. So we can go ahead and connect to make our line. Next, let's take a look at that second equation. Oops, you guys don't need to see that. Let's take a look at that second equation. Do you get a nice little peek? That's when my students are coming in for help, in case you were wondering. All right, so we're going to have 5x plus 3y is equal to a negative 6. So first thing I want to do is get that 5x over to the other side. Again, it's positive, so I'm subtracting 5y from both sides. So then I get 3y is equal to a negative 5x minus 6. So then I'm going to subtract 3 from both sides, and then y is equal to a negative 5/3 x. 6 divided by 3 is a negative 2. So we're crossing the y-axis at 2 here, and then we're going down 5, 1, 2, 3, 4, 5, over 3, 1, 2, 3. So to me, it looks like they maybe should have hit right at that point right there. Remember, graphing isn't the most accurate way. Okay, so it looks like they were maybe going to hit that way. So if that's the case, we went over 3. We always put our x first. And then we went down 6. So over 3 and down 6. That would be my estimated crossing point for that one. Okay, let's take a look at this next one, number 4. So first thing we want to do is solve each of the equations for y. So let's take a look at the first one. Come on. All right, so we have negative 4x plus 2y is equal to 2. So I'm going to start by adding 4x to both sides this time because that 4x is positive. So I'm going to add 4x to both sides. So I get 2y is equal to 4x plus 2. Next, I want to divide both sides by 2. And then I get that y is equal to 2x plus 1. Okay, because 4 divided by 2 is 2, and 2 divided by 2 is 1. So we're crossing the y-axis at 1, and then going up 2 over 1, and graphing that first line. Let's take a look at that second one. Well, that second one is already solved for y, so I can go ahead and I can graph it. Okay, so for that next one, we're crossing the y-axis at 4. So we're crossing at negative 4, and then we're going up 2 over 1. So what I noticed about those two equations that I just made is that they have the same slope. Since they have the same slope with different y-intercepts, they're going to be parallel. Now remember, if they're parallel, that means we have no solution. Okay, so let's take a look at those couple word problems on the back. So for the first one, Monica and Max Gordon each want to buy a scooter. Monica has already saved $25 and plans to save $5 per week until she can buy the scooter. So let's start with Monica. We're going to let y equal the total money. So y is equal to the total money that they saved. We're going to let x equal the number of weeks. Okay, so let's go ahead and set that up first for Monica. So Monica, she's starting off and she has $25 saved. And for every X week that goes by, she's going to save $5 for each week. Then, taking a look at Max, she has $16 per week. He starts $16, and for every X week that goes by, he's going to do 8. So now I want you guys to pause the video and go ahead and try and graph it, or you can just graph it with me. So I'm going to go up by 2 since I can't go all the way to 25. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24. So 25 is about right there. And then I need to go up 5. Well, I need to take into account the fact that I'm going up by 2s. So that's going to put me here. And then I'm going to keep my x-axis as going by 1s. So this guy is by 2s and this guy is by 1s. So I'm going to go ahead and graph that line right here. Then I'm going to graph 16. So here's 16. Then I'm going up 8. So 2, 4, 6, 8 over 1 is here. So now I want to estimate that point in which they are crossing. So I'm going to look how many I'm going over. So I'm going over 3. So after 3 weeks, since X represents weeks, so after 3 weeks, they'll have the same amount of money. Then I want to figure out how many I'm going up. So I'm going to count by 2s up to that point. And when I do that, I get about $40 when I count by 2s to see how far up we went. Okay? Next, let's take a look at this next one. The number of girls participating in high school soccer and field has steadily increased during the past few years. Use this information to predict the year in which the number of girls participating in these two sports will be the same. So let's let y, again, equal our total number of girls. So y is going to be our total, and x is going to represent the number of years that are passing. Okay, so for every year that goes by, we're going to start by having 8x plus 309. Okay, so we're going to have start at 309, and for every x year that goes by, it's going to increase by 8. Next, for the next one, we're starting at 418, and for every x year that goes by, we're going to go up by 3. So now we need to graph. Okay, so it's kind of hard to graph, so I think I went up by about 10s or 15s, maybe even 20s. Okay, so when you go up by 20s, 309 is about here. And then we're going up 8 and over 1. Remember, this is not going to be exact, okay? So just get the best graph that you can, because doing it this way is not precise. And then we're crossing at 418, but we're going up a little bit less. So now we want to see what that point is. So we want to figure out how many years that is. Well, that's 1, 2, 3, 4 years. So we're going to guess about 4 years. And then I want to count up by 20s to see about what this point is going over. And when you do that, you get 480, but that's in thousands. So that's 480,000 girls participating in those sports. Let's take a look at that last word problem. So Tyler and Pearl went on a 20-kilometer bike ride that lasted 3 hours. Okay, because of the steep hills and why they had to walk for most of the trip. Their walking speed was 4 kilometers per hour. Their bike speed was 12 kilometers per hour. How much did they spend doing the activity? So let's let X represent the hours walking, and y represent the hours biking. So between the 2 hours doing each, it needed to be 3 total hours. Then, for every x hour they spent walking, they went 4 kilometers. For every y hour they spent riding, they went 12 kilometers. And they want that to be 20 kilometers, because that's how far they went. So I'm going to go ahead and I'm going to solve these for y in my head just so we can save some time. Okay, so then you end up getting that y is equal to a negative x plus 3. And you also get that y is going to be equal to a negative 1/3 x plus 12 divided by 20, which is about 1.67. So now we need to go ahead and graph this. So it's going to be really, really small on the corner of our graph. So it's going to kind of look like this. Okay, so it's going to be really, really, really tiny where those points match, okay? So this is 1.67, then I went down 1 over 3. This one is crossing at 20, and then I went down 1 over 1. So this point is where they're crossing, which is at about 4, 2. Well, what does that mean? That means we spent about 4 parts of an hour walking and 2 parts of an hour biking. Okay, so that is going to conclude our notes video for today. So show me your completed note sheet and I will get you the homework. Thanks for listening.